Hello, everyone. The purpose of this presentation is to discuss a feature called AWS Split Cost Allocation Data, which we'll call SCAD henceforth, and some of the challenges that customers have with using this feature. So to begin with, let's discuss why SCAD was created in the first place. AWS has really two ways in which you can run containers on the infrastructure. The first is using a AWS-specific orchestrator called Elastic Container Service, ECS. And the second is using an industry standard orchestrator, which is Kubernetes-based, called Elastic Kubernetes Service. So both these methods have either the serverless mode or the server-based mode. In the serverless mode is called Fargate, and the server-based mode is called ECS on EC2 or EKS on EC2. So there are really four methods: EKS on EC2, EKS with Fargate, ECS on EC2, and ECS with Fargate. So this shows those two serverless and server-based modes here. On the right is a serverless mode, which is the Fargate mode, and it actually shows some containers, right? In this case, there are 6 container tasks that are running, and on the left, it shows the same 6 container tasks, except that they're running within the context of an EC2 instance, right? So in the serverless model, which is a Fargate model, the customer is only charged for the actual consumption and running of the containers, consumption of AWS resources, CPU or memory. Whereas on the server-based model, they're only charged for the EC2 instance itself, and you can run the container workloads on top of it, right? So those are the two differences. So the reason SCAD was invented was because in this server-based model, you only have visibility of the EC2 costs and not the visibility of the container level costs. So for example, if you have multiple departments running containers, you don't know how much of the cost should be allocated to each department. So say suppose task 1 was marketing, task 2 was engineering. So if you don't have visibility into container level costs, you do not know how to do this allocation, right? So this is why SCAD was created, to break up that EC2 costs into the underlying container costs. Now, before we go into more details on the costs, I just wanted to give a brief primer on microservices and containers. So really, there's two ways in which applications are architected. On the left here is the monolithic mode, and this is by far the most popular mode of running and creating applications. So let's assume that we have a small photo editor application, and the customers will log into the mobile app and basically will be able to upload pictures and then edit the pictures, add some effects on it, and then store them in the cloud, right? So that's what this application does. That's the functionality of the application. So when all of those functions are actually implemented using a single monolithic app, which is running on the AWS infrastructure. In this case, the app itself is running on EC2 instances. And when the customer stores the pictures in the cloud storage, is actually being stored into Amazon S3. And then any details about the user information is actually stored in the user database, which is basically an RDS instance. So this shows a monolithic app because one single application is providing all the functionality of the application, right? On the right-hand side, though, you can see the microservices architecture, where the front end, either the mobile front end, mobile app, or the web app, or an app on the TV device, is connecting to the cloud. But in the cloud, there are multitude of microservices that are running, and instead of a single monolithic app, and each microservice provides some functionality. For example, the auth service provides the login functionality for users. The search service provides the ability for users to search for titles, movie titles. And then the order service maybe is when the users sign up for Netflix service, right? So there are multiple, each microservice is providing some functionality, and they have their own storage information, storage databases, and the microservices will then communicate with each other as needed, but they can scale independently. So when the application is large and complex, it is better to implement a microservices architecture. So that way it is, each service can scale independently, can function independently. So this shows the same picture as that previous, as a Netflix microarchitecture, except it shows it running as containers. In this case, the auth service has 2 container instances, and the search service is running 3 containers, maybe because there are a lot of people doing searches, so more search containers were spun up, and then there's 1 order service running. On the left-hand side, it's the same number of container instances as on the right-hand side, except that you can see that they're running in the context of an EC2 instance, within an EC2 instance, an auto-scaling group comprised of 2 EC2 instances in this case. Now, this is the same picture as before, but with additional details. It is showing that the auth service is using a database. The search service is all talking to its own database, and so also the order service. And the same thing is shown on the left-hand side as well. And you can see that the resources are all tagged with resource tags, right? All the blue stuff belongs to the auth microservice, and they've been tagged with allocation : auth, right? So the costs corresponding to the container and the cost corresponding to the database needs to be allocated to the auth service. And similarly for search and order. And this is exact same thing on the left-hand side, except here you have the EC2 instance as well. And in this case, the EC2 instance has been tagged as allocation, not container, both these EC2 instances, because the allocation is not to a specific container, but you just have costs associated with the EC2 instance. Okay, so there are a few observations that are important to make here. The first is the EC2 instances are actually not just running containers. They may be costs associated with other things that the EC2 instance does. For example, there could be costs associated with data transfers in and out of that EC2 instance. There could be costs associated with the EC2 talking to a block storage like EBS. So all of these will be reported as under the product of EC2, right? But all those costs are not getting split up. It's only the run instance operation costs that are being split up into the container level costs by a SCAD. Also, you can see that there is capacity here that's not being used, but you're paying for the EC2 instance. Whether or not you're running containers, you basically have to pay for the EC2 instance. And so these would be unused costs, right, of the EC2 instance. And then the third is that, as we said before, these microservices are using their own databases, but the databases themselves will not be split up because they don't need to be split up because they're not shared across microservices. It's a database that's allocated just for auth, and this database is allocated just for search, and this one for order, right? So those are important observations to keep in mind. Now let's take that left-hand side EC2 instance. Let's take this one EC2 instance. It's running the auth and the search, and look at some cost information. Okay, so let's assume that EC2 instance is tagged allocation not container as before, and let's assume the cost is $100. Now, as we said, it's doing both run instance operations where it's actually running the containers, and also there's some non-run instance costs like data transfers. Let's assume that cost is $18, right? So the $82 for the run instance is then split into how much each of these containers cost, like $30 for the auth and $52 for the search, right? Now, as we said before, there is some unused capacity, right? So the actual cost of that container itself is only $13, but there was an unused cost of $17, right? So both those together add up to the $30. So, and similarly for the search. Now, if we said, what is the cost of the auth service or auth microservice, we would basically be adding up the container cost as well as the RDS cost, right? So it's $10 plus only $13 of the $30 because only that was used to run the containers. The remaining was unused cost. So 13 plus 10 is $23 is associated with the auth service. Similarly, for the search service, it's $20 for the DynamoDB plus $15, which is $35. So the first goal was to find the cost of each of those services that we're running, and we've figured that out in this box here. Then the second goal is what are the costs that are left unallocated. And if you look at that, it'll be the unsplit costs, which is the data transfer cost, $18 were unsplit, and also the unused costs. So 18 plus 17 plus 37, and that's $72 of unallocated costs. These are costs that cannot be allocated to either auth or search, but we need to allocate it somehow to something, right? Either the IT department or we then just split 50-50 between auth and search. We have to do some allocation. So that's the second goal. First, what is the cost of each of the microservices? And second is what is left unallocated after the microservices are accounted for. Now let's look at how SCAD generates this data and what it actually does, right? By looking at a Kerr snippet. So if you did not have SCAD, you will only have the first three line items in this Kerr snippet, basically. So the first line item corresponds to the RDS instance, and that's costing 20 cents in unblended cost. And then you have this EC2 instance that we're talking about, which is 12345 is the resource ID. And it is doing a data transfer. Public IPN is a data transfer cost of $320, and there is some run instance cost of $50. So it is this run instance costs which are getting split up. Okay, so without SCAD, we will only see these original three line items. With SCAD, it produces these new rows, as well as SCAD produces new columns. And these columns show which is the resource that's getting split up. So the parent resource ID is the 12345, and also shows new cost types, split cost and unused cost. And there's a couple more, net split and net unused, right? These really are a form of amortized cost and net amortized cost. So if you look at the formula here, it says amortized cost is split cost plus unused cost. And similarly, net amortized cost is net split plus net unused. So these are really the costs that SCAD is producing is really a form of amortized costs. And of course, the Kerr will produce tags for you because you've created the tags and you've enabled them as cost allocation tags. So the first line item corresponds to the RTS instance, which was tagged auth. And then the second two are, second and third are belonging to the EC2 instance, which we tagged as not container. And then the remaining are belonging to the containers, and they've been tagged either as auth or search. Right, Paul. So now, without SCAD, without these rows and these columns, if we just said what was the cost of the auth service, for example, you'll be filtering this Kerr with this auth tag, and you will only see 20 cents. And that's really the problem, right? Because you wanted to be able to see the cost of the container as well. So now that we have this SCAD rows, let's see if we filter this Kerr snippet with auth, what we'll do. It'll be 20 cents plus what? There is nothing here to add up because SCAD doesn't populate all these original cost types, right? It creates this new cost types. So, okay, so let's see, can we use this split cost, which is basically amortized cost? We could try to use it, but it doesn't have any, the original costs don't have the corresponding amortized costs. So this is one of the problems, right? The original cost types are blended costs, unblended costs, savings plans, effective costs, etc. And those don't exist for SCAD. And the SCAD produce data has amortized costs, which doesn't exist for the original cost. So we cannot aggregate these costs using cost allocation tags in order to report the cost of the container, right? I mean, the microservice. So that's problem number one. Then the second goal that we said was, besides trying to find the goal of the each individual microservice, we said the second goal was trying to find the cost of the unallocated costs. So in this case, the unallocated costs are, as we said, the unsplit costs corresponding to non-run instance, which is this 320, plus we said the unused cost, which will be this, right? This column here. But again, this has the same problem because this is of a different cost type, and SCAD produces different cost types, which are basically amortized cost types. So it has that problem. But in addition to that problem, it is kind of difficult to figure out which line items we should pick out, right? Because what you would need to do is step one, go into this column using the resource ID, figure out which are all the resource IDs which are being split up. So 1, 2, 3, 4, 5 is the resource ID that's being split up. And then take the rows that don't correspond to the run instance costs, take that cost, convert that into amortized cost, add the unused cost to it. So you need to do all of that to figure out what is the unallocated costs, right? So these are the two problems. The goal was to figure out what the cost of the microservices were using these tags, and we can't do that. And then we can't also figure out what are the unallocated costs. And this creates a huge problem with the usage of SCAD. There are other problems, some other problems like, why does every resource have to be split up, right? Perhaps every EC2 instance doesn't have to be split up, and we could use some tags to figure out which one needs to be split up. But SCAD doesn't provide this flexibility of selecting the EC2s to split, because splitting like this, obviously, as you can see, is going to explode the curve, but SCAD doesn't provide that flexibility of selecting resources. So that's another problem. But the data that SCAD is generating cannot be aggregated using cost allocation tags in any straightforward manner that I can see. So it'll be very helpful if AWS actually produced a query or provided some guidance on how to use this data that SCAD is generating, and how to aggregate this data using cost allocation tags. So that's all. Thank you.